Hi there. All right, so today is just a continuation of yesterday, still looking at graphs of sine and cosine functions. And today, though, we're going to flip it around. Instead of me giving you the equation and you have to graph it, what if I give you the graph? Could you write the equation? So that's all we're doing today. One of the areas that people tend to get confused is using trigonometric vocabulary like amplitude, period, phase shift, vertical displacement, versus writing using transformation terminology like shifting, stretching, reflecting, those kinds of things. Sometimes those are equivalent vocabulary, but sometimes they're not. So let's look at this example. I messed it up as much as I possibly could, and we're going to go through this one and talk about the trig verbiage versus transformations. First thing we got to do is, just like we did previously, is you've got to factor that b value out of there. So I'm going to factor out this 2. Now remember, when you factor, you're dividing. So I'm taking a pi over 2, and I am dividing it by 2, which is the same as multiplying by 1/2, which means that would be a pi over 4. Oops, close that off. Okay, now let's go through what we learned yesterday on the terminology. The amplitude of this graph would be considered 4. Remember, it is always the absolute value of the a value. If I was talking in terms of transformations, what does that a value do? Well, I know that the negative is going to make it reflect, so that still does play a part. And I would have to distinguish what it's going to reflect over. So it will reflect over the, what do you think, x-axis, y-axis? Yeah, it flips upside down. It's going to flip over the x-axis. The 4 is going to do a stretch of it, but is it a vertical or a horizontal? Vertical. I don't know where I wrote the 4 first. This is a vertical stretch by a factor of 4. All right, let's go to the next letter, the b value. Okay, that b value is not the period, but it does affect the period. Remember that it is going to be 2 pi over the b value. So the b value that I factored out was a 2. So then the period of this sine or cosine wave is going to be pi. Now, if you're talking about transformations, if you start changing up the period, what you're doing is you're shrinking it or stretching it horizontally. So in this case, since the period shrunk, this is going to be a horizontal compression, or I usually use the word shrink. Now let's think about this. If you're shrinking it, it's got to be a fraction here. And since it was a 2 that we factored out, it shrinks by 1/2. It's always the reciprocal of that value. All right, the next value is going to be the c. That c value is your phase shift, but only after you've factored the b out. So this is not your phase shift. This is your phase shift. And you always do the opposite when you're inside those parentheses. So my phase shift is actually negative. So I'm going to write negative pi over 4 for the phase shift. But if I was talking about transformations, I'd say that it's going to go left pi over 4. So if I talk about phase shift, it's just a number. Don't be putting the word left here. You put a negative on that. Okay, last thing, vertical displacement. That's your d value. And so again, just like earlier, vertical displacement is a value, not a word. So I'm going to say the vertical displacement is -3. But if I'm talking transformations, I'm going to say that it goes down 3. So try to keep those words separate from each other and pay attention to what's being asked. Am I asking about transformations, or am I asking you to use this trig vocabulary? So here we go. I'm going to give you a graph. We're going to figure out what the equation would be. As you do this, you're always thinking of this format. And this is a sine graph. So a sine, and then there's going to be this b value. And then I'll have x minus c inside here, and then a plus d out at the end. And can you identify, based on that graph, what all of those values are doing? So you're sort of tying together this idea of what transformations are happening, and then I'm turning them into this A, B, C, and D in this equation. So first of all, let's talk about the A value. All right, that's any vertical stretch, and it looks like it's going to 1 and -1, so there is no stretch. It could also be a reflection, but remember for a sine wave that it starts in the middle, heads all the way up, all the way down, and back to the middle. And that is exactly how this graph starts. It starts at the middle, headed up. So I also do not have any sort of reflection going on. What that means to me then is that A is just going to be 1. It's not going to change at all. Okay, next thing, the B value. The B value is that horizontal stretch and shrink. So when I look at my graph, I am going to see how much stretch or shrink there might have happened. And that really has to do with the period. So if you follow this wave, usually what I do is I see what's happening here at the beginning at 0, and then I track the graph the next time I'm at that exact same spot. It's not here because I'm headed down. I want to go to where I'm at 0 headed up, and that's to right here. So one wave has a period of 6 pi. Now, you can do the little formula, but I'm going to bet that a lot of you are able to do this without. So if you think about, was that a horizontal stretch or shrink? Okay, it's stretched by how much? By a factor of 3, because it's supposed to be 2 pi, and now it's 6 pi. So it's stretched by a factor of 3, which means then that the B value, remember you always do the opposite when you're inside there. So if it's a stretch by 3, my B value is going to be a 1/3. Now, if that's tricky for you, you could always set up the formula. Remember that 2 pi over B is going to equal the period. So I could set it up, do a little equation, 2 pi over B is equal to 6 pi, multiply by B, and then come back and divide by 6 pi. Now you can see this gets kind of lengthy, so if it makes sense in your head just to do it, you're definitely better off. B is end up equaling 2/6, which reduces to 1/3, which is what I had. Okay, let's go on to the C value. The C value is any phase shift. And then we're back to this picture here that says, well, sine is supposed to start at 0 headed up. And looky there, it is. It's at 0 headed up, which means I do not have any phase shift to worry about. So my phase shift would be 0. And then the last thing would be the D value, and that's any vertical displacement. Did this thing move up or down off of the x-axis? No, it did not. So the D value is also 0. If I'm going to write this equation, then here's what it's going to look like. Y equals, there's no sense in writing that 1 for the A value. I'm just going to write the sine of, all right, I've got a B value of 1/3, and basically everything else is just zeros. So this could be 1/3, and you can use X or you can use theta, either one. I try to use both. I guess I'm going to use theta today. That's one way of looking at it. Probably would have parentheses. I'm going to tell you that more often you're going to see it written like this. Instead of 1/3 theta, you're going to see it theta over 3. And that's what it was like on your homework yesterday also. All right, so let's try it one more time. Again, it's going to be a sine graph. So in my mind, I'm sitting here thinking, well, I got this equation. It's got this A value. It's got the sine of, and then I have a B, got a C value to worry about, and also a D value. Let's see how many of those have a change in them. So again, here's what the sine wave is supposed to look like. And I can tell that it does not start like it's supposed to, but let's do this in order. Let's start with the A. That's any vertical stretch. Okay, yep, I can see this went clear up to 3 and went down to -3. So it stretched 3 times farther than it normally would. So that's going to make my A value be a 3. The B value deals with any horizontal stretch or shrink that's going on. So again, like I said, I like to just start right here at 0 and see when is the next time I'm going to be at that spot. So the minimum happens here at 2 pi. All right, what that means is that the period is 2 pi. Now, it may feel like, well, hang on, this is what my sine wave is supposed to look like. Well, I could do that too. I could go from here up and all the way down to here. I just feel like, okay, now I have to figure out how far is it from pi over 2 to 5 pi over 2. And it's easier for me if I just start at the 0 line because it's still going to be a full sine wave wherever you start and stop as long as they are matching spots on that wave. That's why I like to start at 0. That way, boom, I immediately know whatever that is, that's going to be the period. And 2 pi is supposed to be the period. So that means that B value isn't going to be a value that I need to change. I'm just going to leave it a 1. Okay, let's talk about the C value, any phase shift. Remember, it's supposed to start at 0 headed up, and it definitely does not start at 0 headed up. So I kind of scroll over here and see when is it that I'm at 0 headed up. Right here, I'm at 0 headed up. I needed to shift this thing over pi over 2 units. So then my phase shift is going to be pi over 2. And then looking at it, it does not look like it went up or down off of the axis, so there is no vertical displacement. Here is my equation. Y equals 3 sine. I don't have to worry about the B value. It's just going to be a x minus, or it could be a theta, either one. Like I said, you choose what you like. I try to mix it up just so that you're familiar with both types. X minus pi over 2, and then I don't even write the D value. And there's your equation. Let's try a cosine wave. The idea is not really different. It's still going to have the same A, B, C, D that I have to worry about. It's just that it's going to be a cosine graph. And the thing that changes, though, that remember from yesterday, that the cosine graph starts at a peak. Instead of starting at 0 headed up, it starts at a peak, and then it heads all the way down and all the way back up. And that's how one wave starts and finishes. When I look at this graph, I'm going to start with my A value. It looks like I didn't have any stretch because it's still going to 1 and -1. Don't have to worry about the A value. The B value is my horizontal stretch and shrink. So I'm going to start here at 0 and say, all right, I'm at 0 headed down. The next time I'm at 0 headed down is right here. That means the period is 4 pi. That is a horizontal stretch of by a factor of 2 because the period is supposed to be 2 pi. It went twice that. And if it stretches by a factor of 2, then the B value is going to be a 1/2. Remember, it's always going to be the reciprocal. Now, your C value, it has to do with how we think of a cosine should start. It should start at the peak. Well, the first time it's at a peak is right here. So I've got a phase shift of 3 pi. And then again, no vertical displacement to worry about. Here's how I would write this equation. And then again, probably going to write it as, instead of a 1/2 x, probably be an x over 2, could be a theta over 2. Sorry, let me fix that. That's because I have this phase shift, because I have a C value here, I actually have to do that differently. I'm going to do the 1/2, and then I'm going to have to do the x minus the 3 pi. I'm not going to be able to merge that 1/2 and that x because this one has phase shift on it. I've got to keep those separate. All right, there's my equation. However, that is not the only option here. There's a couple other things that we could do. Instead of looking this as though it went right 3 pi, maybe you saw it like, oh, wait, that's going to go over here. And that's actually could be going left pi. If that were the case, if you saw it like that, you might have written your equation like this. And instead of going right 3 pi, I went left. So it's going to be a plus pi. Now, I'm not a super fan of that because I can't really see pi on my axis. So I'd rather stick with values that we definitely see listed out, but it would be correct. All right, but I think maybe the best option would be to recognize that this actually could be looked at as, instead of a shift, maybe you just looked at it like it was a reflection, because you could do that also. Well, I don't know that this is an ideal scenario, because if you did a reflection, instead of starting at the peak, you would start at a minimum. Well, the first minimum I have happens right here at pi. So, all right, then I could look at it instead as a reflection. So I'm going to go with a negative cosine 1/2. And instead of going right to 3 pi, I only have to go to right to pi. So I could do this. All right. I don't care which one of those you write. Well, I kind of would prefer it not be the second one, but you choose whichever one makes the most sense to you. And really, our goal is to probably make this as simple as we can. I'm not sure that any of these is that much more simple than the other. All right, here's our last one. Again, looking at this as it's an equation, this one is going to be a cosine. Let's go through the list. A is your vertical stretch. Now, don't get confused and think, oh, look, it goes up to 3. So my A value is a 3. Not really. This actually has a vertical displacement. I finally gave you one that has vertical displacement. There is, like, if you can imagine, like, this is your new equilibrium. This cuts through the wave perfectly. And so what I'm really seeing happen here is vertical displacement, not an amplitude change. My vertical displacement is 2. And from that equilibrium, I'm still going up 1 and down 1. So there is no change in my amplitude. That's still going to be a 1. Okay, next, I'm going to look at any sort of stretch, horizontal stretch or shrink. Is there a change in the period? All right, here's another weird one. I'm going to be right here, and I'm looking at when's the next time I'm here headed down. So I kind of track it over here. They're headed up. Here I'm headed down. So that would represent one full range of values in there. So it would be considered a full wave, and it took me to 6 pi. So my period on this is 6 pi. Another way you might look at it is, I like to go from peak to peak or valley to valley. So you might go from 2 pi to 8 pi. That would be a distance of 6 pi. There's another way of recognizing from one spot to its next matching spot is the period. And if my period is 6 pi, that means I have a horizontal stretch of 3, making my B value be 1/3. Now let's talk about the phase shift. It's supposed to be starting at a peak. The first peak that I actually see is right here at 5 pi. So I would write that as a 5 pi, and my equation would be y equals cosine 1/3 x minus 5 pi. And then I do have vertical displacement on this one, so I have a +2 at the end. All right, an alternative might be to write it with a reflection. And instead of going clear over here to 5 pi where the peak is, what if I just go to where the minimum is? I just go to 2 pi, but I do that reflection. So instead of being at a peak, it's at a valley. So I've got the reflection going on, 1/3 x minus 2 pi. There's another option. Still have the vertical displacement. Third option, not my favorite because it goes off the graph, but maybe you can see that, oh, that would happen at a negative pi. And that will become problematic for us later on when we start doing stuff on our graphing calculator. So again, not my favorite option here, but it would work. Where you're going to the left, so you put a plus sign, pi. All right. Hope this helps, makes sense to you. Go work on your homework. Good luck.